one is light and another one is eye, and we can see one image when the light is reflected on our eyes from any object or anything. That time we can see the object. And fixed light, that means whenever the light is reflected from anything, and we can see that color, that means the other colors is absorbed by the medium, and that color is absent in this sense, and we can see that color.
Okay. That so what about the structure of the eye, that the working process? You can you maybe see in the screen. We discussed about that iris or cornea, right? Then the retina, the structure of the retina. What do you have? What kind of sensor?
Yes, sir. The lens here can structure. The retina is used for form the image, and the rods and cones are the element or part of the eye that senses the where the object is located, or from where we can see the light, and these things.
Okay. Okay. Thank you, Tasha. Anyone else can detail can say about, so far you can remember, maybe even you can see from the screen that how actually the object create, or maybe have a relationship with the visual cortex, that at the end of the day we get it from the retina with that optic nerve. The signal actually process go through from that retina to visual cortex, that means in our brain, and where high level functions are actually happen. That what kind of high level function that it can have. Atik, Faisal, Iman, can
Yes,
you hear
sir.
me, Iman?
Yes.
Yes.
Yes,
So
sir.
what kind of that high level function that they happen in the visual cortex?
Sorry, sir.
Okay. Uh, yes, all right. Antor, can you tell me? You can try from your common actually understanding as well. It is not that you need to have it. Like when we have an image, that image you also need to actually recognize it, right?
Yes, sir.
And for recognition, what do you need?
Data about the object.
Data about the object. Exactly, Mantakimur. So that if you have some information about that object already in your brain, then you can actually identify it. Otherwise not. Otherwise not means actually that object, this is the very first time you are seeing. Okay. So whenever you see that, that information is actually stored in the brain. So next time when you will see, then actually that double check, they do double check to find out. So those kind of activity are actually happens in the visual cortex of the brain, that we have said like is a complex activity. Okay. About that resolution on that retina, that we said there are sensors are working, two type of sensor, rods and cones, while the sensors which is actually working in the low level light, that means at night, okay, that is spread over everywhere in the retina, that is called the rods, right? And which sensor is actually have working for the high level, that light, that means in the daytime that sensor works. That is especially if we have in a some spatial area in the retina, and that spatial area is actually called the fovea. Okay, and the fovea is mainly for high resolution because that part maybe in the daytime you can see better, as you can see that you can also uh, find out the objects maybe for the far distance also you can actually see it. So that's why in the fovea, that high resolution area, there the cones are actually over there working for those sensor in the daytime. We also have seen there's no very specific reason that why the green color gives us some kind of sensitivity and red and blue are not. How we can identify that this colors are actually related with what in the light?
Wavelength.
With the wavelength, different wavelength. Okay, so the wavelength or maybe frequency, we can take any property of the length wave. So the wavelength for green, that means that electromagnetic wave in that spectrum for the light is different from the red or different from the blue. Okay, and also in between they have the combination. We have seen that this is actually the visible, that part for the light as having a different wavelength for it. Also you can see here with the different wavelength actually the colors are actually different. Okay, so that is about the human visual system in the working process. Usually we can have it, but in the online exams, mostly I don't actually ask this because the student do the copy from the slide. Rather than in the Viva exam, if you have, then you definitely have something from here to ask about the structure or maybe the components of the eye that we have. Then we discussed about object actually in an image, what actually the object means in there. So this we try to actually discuss from the point of view of object-oriented programming. That in the object-oriented programming, how the object has a relationship with other actually the work. So we have seen that it is actually related with the class. Then what is actually class in object-oriented programming? We have seen that this is an well, any specific entity or component that is actually we are segmenting or we are separating, and also we are identifying that entity or components, that the properties of it, and that properties have some also behavior. That means the attributes, that is actually we are calling the method as well. So from that actually perspective, we try to discuss about the image, what objects actually means in here. The objects are actually having attributes. Okay, also the primitives, if we consider from the geometrical perspective, that any object has the primitives. That means it has points, line, polygons, right? And those are actually created that object or making that object. And the attributes also line, style, the color, the surface texture, that how it looks like on the body. Okay, and connectivity relationship and positioning data that describe the how components are fit together. So this is also, they have a relationship with object to object, how they can be actually have a relationship. It has a relationship in the image. When we have, you can find out like it has a relationship. And the virtual environment. Just for any object to object relationship, we can say like when you are actually say like a building, and we can see the sunlight, the sun is actually have a movement, then the shadow of the building that you can see is automatically it change. And this is the relationship with one object to another object in the image, as you can see. So that if you are doing an animation actually program, you are writing for that same image, say like IBAT building, and that the sun is actually from east side to west, it is actually moving, that in your animation. So you are not actually doing anything, rather than the shadow you can see on the building, that you have to have your program automatically according to the position of the sun, the shadow size and the actually length or everything will be changed. So that's actually called the interrelationship between the objects. Okay. All right, let's come to the video. Let us finish the attendance, then we will continue from here. Okay, we have Alif Laila Jannat. Alif Laila Jannat. Do you have Muhammad Ashikur Rahman Ashik?
Yes, sir.
Ashik,
Yes, yes, sir.
yes, got it. Ashik, Alamin.
Yes, sir.
Okay, Alamin. Nishat Ara. Nishat Ara. Shahidul Islam Antur.
Present, sir.
Okay, Antur. Sumaya Akhtar.
Present, sir.
Okay, Sumaya. Arifa Akhtar Ritu.
Present, sir.
What about your video, Ritu?
Sir, it's on.
Yes, yes, Allah. Got it. Jinatun Nisa.
Yes, sir.
Okay, Jinat. Parvez Alam. Parvez Alam. Redwan Ahmed Ratul.
Yes, sir.
Okay, Ratul. Salvi Saba.
Yes, sir.
Okay, Saba. Jakaria Hassan Papu.
Yes, sir.
Okay, Papu. Maria Mehjabin.
Present, sir.
Okay, Maria. Israt Jarin.
Present, please, sir.
Israt Jarin.
Present, please, sir.
What about your video, Jarin?
Sir. Sir, I have some problem, sir.
Okay, Abdul Khalik. Abdul Khalik. Ravina Afrin Ami.
Yes, sir.
Are you there, Ami? Yes, got it.
Yes, sir.
Tajnova Yasin Yesha.
Yes, sir.
Kesha Sharia Tayan. Sharia Tayan. Hussein Ahmed Antur.
Present, sir.
Okay, Antur. Pruttasha Roy.
Present, sir.
Okay, Pruttasha Sharnika.
Present, sir.
Khadija Rahman Ria.
Present, sir.
Are you there, Ria?
Yes, sir. Present, sir. Hello.
I cannot hear you.
Present, sir.
Yes, now got it. Rahat Islam Rupu.
Present, please, sir.
Okay, Rupu. Mahmoud Akhtar.
Yes, sir.
Okay, Mahmouda. Didar Al Mahmoud. Didar Al Mahmoud. Tamanna Tabassum.
Yes, sir.
Okay, Tabassum. Saif Mahmoud Sifat.
Present, sir.
Okay, Sifat. Fairuz Tanjim Achal.
Yes, sir.
Okay, Achal. Sadiatun Nisa Shetuli.
Yes, sir.
Okay, Shetuli. Mustafa Iram Udoy.
Present, sir.
Okay, Udoy. Sadia Hussein Mauri.
Present, sir.
Okay, Mauri. Sadia Akhtar.
Yes, sir.
Okay, Sadia. Mantakimur Rahman.
Yes, sir.
Okay, Mantakimur Atik Faisal Imon.
Yes, sir.
Okay, Imon. Rahul Devnath.
Yes, sir.
Okay, Rahul. Nishat Tasnim Jyoti.
Yes, sir.
সর্বনাশ
Yes, sir.
Okay, Tariq. Ashikuজ্জামান.
Yes, sir.
Okay, Ashik. So that we have 9 people absent. Hmm. All right. So few of the things about that already are actually common term, as we already know, like virtual environment. As you all know that what is virtual environment, right? An environment which is virtual, right? You see that the main thing is why the animation is so expensive. Can anyone tell me that why the animation is so expensive? As you know that animated film or maybe whatever they do, uh, they become a little bit expensive. The reason is, Ashik?
Sir, first they have to draw the picture, then they have to create so many pictures. Then
Hmm.
uh, they will have to visualize those and need to make move. Which
Need to make move. Okay. So you see that this would be very easy if you take some real life image through the video camera. Say like you take that video and actually you can use it. That's but if it is in animated one, that means you are creating a virtual environment. Okay, and creating virtual environment, that definitely very difficult, because you have an imagination, you are drawing it, you are creating those objects, then you are having some movement of it. The entire thing is actually quite expensive if you go for using some application or maybe software, and also very complex programming are there. Now, so virtual environment, or VE, which is common term that you know, have the independent objects. That's actually the thing. When you go for real life images, the objects are not independent in that sense that you cannot control them. It is automatically controlled. So according to your imagination, you cannot control them. So that independent objects following some law and behavior define a world. Okay. So I just told you, like the movement of the sun and the IVAT building, say like in the cancer hospital building, and you can see that it is actually from east to west. When it is moving, then definitely there are some law behind it. Like east to west, it will go. The shadow, when it was in the one side of the sun position, then the shadow was longer. When it is actually the position of the sun is on the top of the head, then you can find the shadow is actually becoming smaller, right? So according to the geometrical law, that these changes of the objects, and from object to object has a relationship, the shadow itself also another independent object. Now you can actually do many things. If you want to have say program, writing program of those objects individually, then you can do it according to your wish. The sun having movement from north to south, you can do it, right? But in the real life it is not. The virtual environment have three components. One is the content, especially the objects, what actually they make up the environment. The geometry, that means the dimension, the metric, and the extent of the boundaries of the environment. So those are actually the related, that which dimension it is, or maybe if you think about the boundary from that image boundary, or the object to object also actually the boundary. And the dynamics are actually the rules of interaction between the objects, so that one object to another object, when they are actually interacting, how they are interacting. The sun is having movement, the shadow of the building is changing. This is all actually interaction. You see that you are not actually extending through your program that length unless the position of the sun is actually have a movement. Okay, so that this is the interrelationship one to another. So that is actually called the dynamics. So part of the automatic movement actually, that we can say. Okay, so content, geometry, and the dynamics, in three technical terms that we can say, this is actually the virtual environment. So
In the
in
Unreal Engine, we can add the physics to it, so the dynamics are more ultra dynamic.
sorry, Uday, I missed the first word you have said.
Okay, sir. So I was saying that in the Unreal Engine, we can add the physics of the each and every particles of the animation. For an example, here we can see an snowball. If it is an object, we can add physics, so it can move according to the law of physics. If it flies, it will make the contact with the ground. So what is the ground? It will calculate about the so the all the things are added in the physics section.
Yeah, that's all part actually comes for the physical law. That rules will come actually definitely when you have at first the object, that when you what you are making, so that object has actually shape, and for that shape you are going for geometrical primitives, right? A very small item that when you create with, and then the rules whenever it is, then this is the interactive rules that already you have said. So definitely the law of physics, as you were saying about the motion, right? When the objects have the motion.
Yes.
So the virtual environment, at any moment, if you have an object, okay, the content, that any moment that the object has actually two things. One is actually the description about that object, and one is actually the state, and state is related with the time, as you know. So the description is information about the object's geometry, the substance and potential behavior, so that actually we can identify what actually the object's geometry at that moment, okay, and also what is the relationship, that the interaction relationship with another object. And while we are saying about the state of the object in relation of the rest of the environment. So definitely when the sun is having a movement, it is actually the light, especially on that entire image, is actually having change. So in every moment, if you just stop and you can find out the position of the object, that means say like the position of the sun, and also actually what is the relationship or the impact it is having on the entire image, that is actually the state. So this is true for any actually thing, the any moving actually the moment of time, means wherever in you have a relationship with the moment of time, then every moment you can actually find it. Say it is also actually we can considering in the computing, that if you have a computing activity, that time also you have a description at any moment, say like t2 second, the t2 second, that what is actually the position of the processor, okay, and in t2 second for the position of the processor, what is actually have interaction with the memory and also with the input output devices. So that's actually the state, okay. Actor, as we have seen the object or content we have said. So actor is actually a special set of objects that can initiate an interaction with another object or actor through information exchange. So you have seen that the example we have put, say like for the sun movement with the building of IVAT building and maybe the building of that cancer hospital, that the movement of the sun is now who is actually initiating the activity on the image, definitely the sun, because it is maybe the only object which is have a movement. Okay, so then the actor first we can identify as the sun, that it can initiate the interactivity with another object. What is the another object? So that with the building, and that the reflection we can see the shadow is actually changing. A participant or an human operator has a visual representation within the environment and controls the behavior of one of the actors. So this is for the animation work that people when they do. So definitely they have within that environment, they try to control the actor or the object's activity. Okay, so the special set of objects, that's just to remember that you might have many objects. Say the example we have put, like we have an sun, we have those two buildings, then the shadows, maybe have some trees, but the main actor in that one is who is actually more locomotive, who is actually moving in there in the animated, because it will control maybe the other objects in the image. Virtual reality. Now, virtual environment we have discussed, and this is actually saying about virtual reality. What could be the possible difference between these two, the environment and the reality?
The reality could be like how exactly the things happening naturally to create that.
But that is called virtual reality.
Yes, sir.
Then virtual reality, how it can happen naturally, because the virtual means actually what?
If we draw an example of science fiction movie where we usually see how the building or the expensive car rack, but if we try to make those naturally, it's impossible and more expensive.
Right. But how you can make a relation like a virtual environment and virtual reality?
So virtual reality means as a human being, we can have senses for our eyes, we can touch. So the five senses that are working. So if we consider our senses to be exactly working in that kind of virtual environment, that can be called as a virtual.
Exactly. Yes. Excellent, Uday. That's the thing. Virtual environment is actually unreal, that scenario you are creating. That's we are creating at first. We are using that word because everything is actually according to your imagination. You can do it anything, right? Which is maybe not present in the real life. Now, when we are talking about reality, reality is into that virtual environment. You are feeling or you are sensing something as like in the real life. So if it is happen, then that is actually called virtual reality, VR. You see that why it is called the VR glass, right? People wear it and they try to feel it through the senses, maybe the only through the visual senses that they use through the eye. An example of virtual reality, it is very common, you can find, say like you are watching a movie, and that movie is showing in one of the scene that the a train is running, and on the side by side maybe a car is actually also going through. The car is driving by a person. Now the image, when you are actually seeing that in your screen, that two of that vehicles is actually running, and you can also see the main actor, maybe he is actually driving that car. Now suddenly you go in that visual perspective, like the person who is driving the car, from his position, how he is actually looking at on that image, he can look at that there is a train is going through by side, and he can see from the screen that he is actually driving the car. So from sitting inside the car, how he will look at in the front, that view whenever you will see, that is actually the virtual reality, because that moment you are taking actually the senses of the actor. Okay, so that's actually called you become the participant on that moment in the virtual environment, and then actually you can see that virtual reality. So the virtual environment, you are actually experiencing it, that is actually called the virtual reality, right? So participant lives in the virtual environment, see with the eyes and the actor, and feels as being the actor itself. That is actually called the virtual reality. The participants' movement are captured by a tracking system. So do you understand that what is VR or virtual reality, and how it is different when we define the virtual environment, right? So yeah, that whenever you feel actually the senses as like the actor does in the virtual environment, that is actually the virtual reality, right? Have you experienced the virtual reality, some of you?
Yes, sir.
with the glass, right?
3D video.
That yes, and
Optimus
also
there has available.
okay, so that definitely that gives you some kind of feeling, isn't it? And also people behave so peculiar when actually you have something like some ride or something with
Yes,
the virtual reality.
Sir, in the some of the virtual realities, we are having the technology called OVR, that we can our smelling senses are also working, so we can have smell from that environment. So
Yeah,
that's more
that
exciting, sir.
also like the movement for I had experience in long time back in one in Bombay, which was called SL World. That time actually it is very few in India even, and I'm talking about almost like 20 years back. So that is the first time I had an experience with the taking off the plane and actually landing, a crash landing of a plane. Actually, we sit 6 people in a room. That was by G World. They had in that virtual reality that experience room in that, and when it was crash landing, then it was really very difficult to sit because people were almost screaming and just jumping. Because that was having some shake. So that room was actually put down in some kind of spring, and the structure that it has actually that kind of movement when the plane is actually taking off and it is actually landing as well. So that senses it was not only the visual, because it was in the room we can see the screen. Maybe you are sitting as like inside a plane, but the exact movement it was happening in your body, that gives actually the horrific experience, in fact. So that next time I thought I should not go for have any virtual reality experience. Okay, forming synthetic objects. The synthetic objects is any object that can be defined according to that geometrical primitives, like points, lines, polygons. So like whenever we say a line, you can see in the space, a line can be defined in 2 vertices, right? So you need actually 2 vertices. We know the vertices are actually what? Yes, vertices are actually what?
Points, sir, points.
Top.
Then what is the difference between points and vertices? Kapu?
I don't.
You don't know? Very critical question, isn't it? You see the point is showing in the vertices in a bracket. That means they are maybe same, but still they are different. What is the difference there?
So vertices implies top of something.
Sorry, Ashiki, what do you say? Top.
Yes, sir.
Top means?
On the higher level.
Higher level, okay. All right. You put some dimension in the thinking there. Okay. Achal, can you tell me what how point and vertex, vertices is plural actually, vertex, how they can be different, or some they are same thing, but there is still something different. When we call vertex, what is the speciality it has? Anything, any idea, Achal?
No, sir.
Okay. Ratul?
Yes, sir. Any specific point, sir?
Is specific point, okay. How could we make it specific? Who can tell anything about it? Sifat, can you tell anything about it? Sifat?
No, sir.
Okay, vertex is actually very technical term in the geometry where you have the coordinate value. Okay.
Does where
So-
two lines meet together?
No, where you have coordinate value. Okay. So in a random space, when you say point, And when you say vertex, then vertex indicate that it has actually the xy coordinate, that value. Okay, so a line, whenever we are saying that 2 points, that means those two vertices, vertices have xy coordinate value, so that you know the actually position of that line in the space as well. Do you understand? So that is the basic difference. The point is actually more general actually term. Vertex is actually more spatial actually term for the same object, right?
So it's the plural for vertex.
Vertex, yes. The singular is vertex and plural is vertices actually. So a polygon also can be defined an ordered list of vertices. That means ordered in here actually that one point, then actually another point values, that another point values, that means the vertex values, coordinate values. Like this way you can create a polygon. Okay, and a sphere can be specified by two vertices. So if you know actually the two vertices value, you can draw a sphere. Means actually what? The circle, isn't it?
Yes, sir.
So what are the 2 points you need, or 2 vertices you need for drawing the circle?
The center and radius.
Radius is a point.
And the center?
No, is the radius is a point. We said if we have 2 point value, then we can draw a circle, right? Only 2 point value you have, then you can draw a circle, a point in the center and a point in the circumference. If you know, then you know that this is actually the radius, then actually you can draw it, right? So 2 point actually you need. If you have actually the polygon, we have said you need an ordered list of actually vertices, like this one, then this one, then this one, then this one, this one, and so this one. So you can create a polygon there. Now what do you mean by the order? As you can see, this point is actually coming one by another. So say like v1, v2, v3, v4, v5 and v6. If it is not ordered, because you now have to think about the programming perspective. Say like I am actually having v1, then I should have say like draw line to v2, draw line to v3, then v4. Now if I have this point value, then if I have this point value, then the definitely the polygon shape will be changed. Then I am actually telling v2, then maybe I'm telling v4 or v5, that only for that sequence, that v1 then it should be v2, v3, like this way. But if I say v1 then v3 then v2, the same 3 points, but their order are different, so it will create different shape. Okay, so that's why it says that you should have actually ordered list of points for the, or ordered list of vertices for the polygon. Okay, this sequence is actually very important. So these are called synthetic objects. That means objects which is created by various geometric primitives. Okay, image and object, very interesting one. You see that that's why we say like many things are actually part of the illusion. We can see and we made a perception, but maybe someone the same thing is actually seeing from a different actually point, and the meaning of that object become different to him, right? Object is not changing, but image is actually changing. So the viewer who is actually viewing, as you can see that B and C, those 2 persons are actually seeing the same object, but the object to them are look like different. So viewer forms the image in 2-dimensional of the object. This is also interesting thing. We have seen that this is a 2-dimensional object. Why it is 2-dimensional object, but we feel like 3-dimensional? So through your eye, you see any object which is three-dimensional are actually illusion. Okay, everything you can see are actually nothing but a snap or an image. Millions of images creating actually one after another so that you can see the movement of it, right? So the same thing works in the camera and film as well. So the human visual system, the image is formed on the back side of the eye on the retina, that already we have seen, and in camera the image is formed on the film plane, so that on a plane actually create the film, the image. Now an object can have lot of images depending on the position and the perspective of the viewer, so that a person who is actually standing in the specific location and also from the distance, that they can see different images, right? So the relationship with the image and object, and they are not same. As you can see, they are not actually same. The object and the viewer both are in the three-dimensional world, but the image they create is actually two-dimension. You see that it's showing that upside down in that diagram here, because we know that it actually creates the upside down image on the retina, and then actually the brain or visual cortex actually convert it in the size. And the light source, already we have seen the light source are actually without light source the object cannot be seen in the dark, because the light fall on the object and then have a reflection and you can actually see the image, right? That day we were saying about any object you cannot see if the light does not reflect, that we have seen about the glass, that light is actually reflecting through, so that it's not coming to our eyes, so that we cannot see. So is there any other scenario that you cannot see the object? Say like the object is it should actually reflect, that type of object, that means not the glass. You also have the light and your eye is actually working fine. Still, is there any situation that you cannot see the object? Anyone?
Sir, if the reflection is too much, which is not capable to catch through our eyes or the devices?
If your reflection is too much, then definitely your eye will actually catch it. If the reflection is too low, then maybe our eye can have trouble. But if the reflection is too much, either your eye will have some trouble, that through that reflection it is hurting in your eye, so that actually it may have a trouble so that you cannot see. That is different. But if it is strong or whatever it is, like you can actually see it if the reflection happens from that object. That's actually I'm saying. Now I said it is the position of the light. You see the this is also very important. If you have something that is actually you see a big object, but your light source is actually behind the object.
Yes, sir, got it.
Then also actually light will not reflect from that object into your eye according to the viewpoint. Now viewpoint is actually important. Okay, so look at in here, this is maybe my viewpoint and this is my object. You can see the light source, so the reflection is happening this side and actually coming to that camera so that you can see it. Also the shadow creates, as you can see, according to the position. Now the sun, say like that source is going behind of it, and if it is behind, somehow the light is reflecting on the other side but not coming in this point of the view. If it is, then also you cannot see, right? You see that whenever we hide the light, by somehow if you can hide the light, also you cannot see, because light is not actually reflecting on those part where maybe the viewpoint is. Okay.
Yes, sir.
So light from the sources strikes various surfaces of the object, and a portion of the reflected light enters the camera through the lens or maybe in our eye as well. And also you can see, this is actually interesting, that object to object, why some objects are very shiny, why some objects are actually not that much shiny. because again, how much actually they can reflect and how much they can absorb on the basis of it. So if you have a crystal, if you have something like any metal object which is reflecting the light of the most, okay, then definitely you can see that is very bright and maybe shining, so that you can find it, right? So the concern about image and object, the interesting part is who is actually seeing that object. The viewer is three-dimensional. What actually you are seeing is also a three-dimensional object, but the view you are seeing, which I call the image, that is actually two-dimensional. Three-dimensional is kind of a feeling that you get, okay, because into your two-dimensional surface in the retina, it's not possible to create an object three-dimension, right? This does not make any sense. In two-dimensional surface, how you can make three-dimension? So that if you feel that there is three-dimension, then it is actually your sensitivity, or maybe you can experience it, okay? Displaying image, two different type, wireframe image, shaded image. You can see that this is very appropriate when we are thinking about the vector image and the what is called, that is the raster image. So this is actually part of the raster image, and this is actually part of the vector image, because the color with shade according to the light. So you can see this is even different actually shade has been created in this color for that green, only for the light source maybe, which is actually not possible with that wireframe image, because wireframe image is actually creating the outline of any of the object. The reality in graphics is always very difficult to create, because our actually experience through the eye, what actually we can see, that gives actually different perspective, different feeling. Now what actually you can see, this one in the screen, what is that called?
We can consider a box.
Consider a box or a cube, right?
Yes, sir.
Yes, sir. It's a
We
cube.
can call it a cube. Why it is called cube?
All sizes are equal. All
All
sides
sides are equal, and also actually it's in 3 dimension, isn't it?
Yes, sir.
That's why actually it's called cube. Now this image, what do you think the viewpoint where actually you are to see that image?
We can see top, right side and front.
We can see a little bit in the top actually side, right? If we consider that this is actually on the surface, this is maybe on the ground, then this is from the top that you are actually looking at. Now see this object, where are you now? Definitely maybe in the left hand side, right? Your viewpoint, maybe you are standing in the left hand side in there, so you can say the entire left side, and some part of the maybe extended part like this part you can see. So your viewpoint is somewhere maybe that little bit in the upper part, right? The same image, the image has not been changed, as you can see. Now look at in here, definitely the viewpoint is actually different, even the objects that you are actually experiencing. So the reality, that's why it says in the through the image in computer graphics is always very complex, and it all depends up to your visual experience, what actually you do experience, what actually the way you can see, that give you different feelings. Okay, we go for the pixel, a very important part, as we know that this is actually sub-pixel level, right?
Yes, sir.
Why I'm calling it sub-pixel level? Yes, Molly?
স্যার এর আগের স্লাইডেরটা না লাস্টের টুকু বুঝি না রিয়েলিটিটা
So I also did not understand what you said.
Sis, speak in English, otherwise I won't respond.
Yes, Molly?
স্যার স্যার এর আগে স্যার
Previous slide, yes.
I cannot understand what you see this part.
Okay. No, we said like, look, the same image that even for a slight change of adding those of the one of the part that you are actually maybe adding, and you can see that even the viewing position is actually completely changed, right? You did not rotate that object, but you just added that part, and this is actually getting hidden so that you can feel like you are maybe in the left hand side of that object. The same object, you just now added that part, and this part is actually hidden in here, so you feel like that your viewpoint is exactly on the top of that object, right? So
Yes, sir.
that's why it's just showing. It is an actually a discussion that we are having, that look, in graphics, when we go for creating object and the object according to the viewpoint, that it is actually give you different actually feeling, or different way of looking at. Okay, just for through an example that we discussed.
Okay, sir.
All right. Now, this is we are calling it subpixel level. I had a question that why we are calling it subpixel level, not pixel level. This left diagram, that one I'm talking about.
It's a pitch of the whole pixel. Just have consider.
No, I said this is showing is actually the subpixel level. How I am sure that this is subpixel level, not the pixel? It's more than the pixel level, right? That's when we say subpixel, because you can see the primary color as well.
Yes, sir,
Right?
you can
Yes,
see
sir.
the primary colors.
Primary color, as you can see, so it is actually a subpixel level. The pixel level should be actually the combination of those color, right? So the pixel we know is actually in short called pixel, but actually it is called the picture elements. Okay, the picture elements is called actually the pixel. So your monitor can be thought as a piece of graph paper, and that is split into small squares with the help of row and column lines. That is actually called the pixel, and these squares are called picture elements or pixel. So we can actually put the color on those small pixel in different one in the graph paper, especially that you can create the image, right? Now this pixel identification, the identifying a individual pixel, say like this pixel I want to identify, so they are in the graph, as it is in the graph, so xy coordinate and all these things actually comes. It depends up to the axis, as we know that if you want to actually pick one of the color square, identification of the square is done by considering the screen having two lines referencing the x coordinate and the y coordinate, and this would be the geometric, that origin point of the x and y coordinates. So on the base of them, actually I can identify any of the pixel anywhere on the screen. Okay, so y-axis is actually vertical axis. At the y-axis, vertical axis, which is having the top one, that is actually the origin, and it goes like this way. And the x-axis is actually the horizontal one, which is starting in the left top corner and goes on the right side. Okay, so x horizontal axis on the top screen towards the right from the left top, and origin is actually the point at which the x and y axis intersect. So it is actually on the leftmost top on the corner there. And the coordinates are to identify the particular pixel on the graph. So whenever we say coordinate, the coordinate value is actually, say like this one, how far it is from x coordinate, or that x line, and how far it is from y coordinate. That value gives the coordinate value of that object. Okay, so coordinates of a pixel is the position of pixel, is then the pair of numbers, we all know, showing the distance from the x-axis and the y-axis, and they are actually shown in a bracket, usually we know, right? So this is actually the identification of the pixel. Now in your screen, the pixel, the total number of pixel is defined by the resolution, isn't it? That how many number of column we have, how many number of rows we have, and that actually give you that many number of pixel. Like a VGA mode, the common VGA mode, we had like 640 into 480, indicating that there are actually the 640 columns and 640 columns like that, and the rows are 480 of that rows. Okay, so our origin point is actually 0 0. Why it is showing the end point is 639 and 0, while here it is showing 0479 and 639479, one less, isn't it? If it is 640, it says 639. If it is 480, it says 479. Why it is actually one less here?
So does it consider by order? That's why begin from 0.
It begin from 0, yes. As you can see that if it is begin for 0, that means actually as same like in the indexing in array, isn't it?
Yes, sir.
So that when we have 0 0, that coordinate value, for that coordinate value, what is the pixel? The pixel is this one. That means the one number pixel. So when I am having 1 0, then 2 number pixel, right? Then
Yes, sir.
2 0, then third number pixel, like this way it goes. So when it is 639 and 0, then this is actually 640 number pixel. So if I have 640 and 0 for coordinate, that is actually outside the boundary. That's why the boundary point, the last one, it says this should be this point, okay, not that one. The arrow, this point should be 639 and 0, and that should be 0479. Okay, so this is the VGA mode that we know, and from that we will try to identify the address of the pixel. There is a formula. So the next day we will show through that how to find out the address of the pixel. We have some problem to solve. In your exam you will have a problem actually to solve, like identifying the pixel address. Okay, that we will do in the next day, and then we will go for actually starting the algorithm for drawing some primitives. Okay, all right, do you have any question?
No, sir.
Okay, so if not, then maybe we yes, I should have start another class by this time. Okay, see you then on the next day.
Alright, sir. Assalamu alaikum.
Welcome, Salam. Take care.